All right, in this video, we're going to overview the project structure, the computer structure, and the processes of updating the production environment, as well as the process of logging in. So this stuff is incredibly important to understand before we dive in and actually build the launcher, because the process might seem a little complex on the surface, but once we get going and we understand the high-level process involved, it should be pretty straightforward. So,
Sounds like fun. I think we should get going.
alrighty. So let's talk about the computers, the environments that we're going to have our project in, just to get the actors set in place. Now we're going to have a development environment. That is our development computer. That is our actual computer that we will be writing code on. And our development environment is going to have a variety of things on it, such as a database. We're going to have a local database on our development environment that mirrors the production database. We're going to have the website. We're going to have Photon. And we're going to have Visual Studio. So these are kind of the components of our development environment. So basically it's a self-contained MMO environment on our computer. The next thing we're going to have is, where's our code going to live? And it's going to live on a service called Bitbucket.
Alrighty.
Now,
What's a Bitbucket?
Bitbucket is a service that allows us to upload code, both using Git and Mercurial as source control systems. So the reason I chose Bitbucket over GitHub for this particular instance is that Bitbucket allows a unpaid or free user account to have unlimited private repositories, as in repositories, Git repositories or Mercurial repositories that don't have to be shared with everybody on the internet. GitHub, on the other hand, free accounts require that all your repositories are open for everybody, and they also have limitations on the amount of private repositories you can have when you pay a monthly subscription fee. So if you want to use Bitbucket, or GitHub, sorry, you are more than welcome to. You'll just have to make sure to sign up with one of their paid plans in order to have a private repository, assuming that you want your repository to be private. In the case of this project, we certainly do want our repository to be private.
Indeed.
So Bitbucket is going to have our Git repo, where all our code lives. The next actor in our environment is going to be our CI server, which is going to have Team City on it. I forgot how to spell team for a second.
It's alright, you're using all kinds of words that I don't even recognize.
Well, CI stands for continuous integration. And the goal of the way that we're going to architect our project is to allow for rapid deployment to production. Because we want people, especially our students, to be able to log in and play around with the stuff that we're doing, we want to put together a continuous integration environment at the start of this project. So we're going to use a product called TeamCity. So effectively, what the CI server is going to do, or the continuous integration server is going to do, is it's going to pull code from Bitbucket, and it's going to deploy it and build it and test it on production. The goal here is to be able to make a change in development, any change that you want, whether that be to the database, the website, to the servers, to the Unity projects, or to Visual Studio, or, well, why would you change Visual Studio? I don't know why I said that. The goal is to take the changes that we write in development, push them up to Bitbucket, and then have our CI server process those changes and deploy them to production with a single click. This is incredibly important. While putting together the R&D for this project, the single most valuable thing that I did at the beginning of the R&D was create a continuous integration environment in order to publish all my changes very easily. So I highly recommend that you guys do this yourselves, especially if you're working in a team environment or environment where you have customers who might want to be able to log into your service during development. And of course, you want to build with all the stuff in mind so that adding it in later wouldn't be an issue. So if you maybe wrote or didn't write your code with this sort of environment in mind, it might be difficult in the future to put this environment in place. And once you launch to production, this is an absolute must. You want to be able to deploy all of your changes to production with one click. If you can't do that, then, well, you're going to have a very terrible feedback cycle. Another important thing about the CI server is that it will actually store all of the past build artifacts. And a build artifact is the result of a build process. So a build artifact would be an executable or a DLL file that gets compiled. And the CI server will store histories of all of these build artifacts that we'll create over the course of development, and will allow us to roll back any of our changes in case they break production, which unfortunately sometimes happens. The final environment, or the final bits that we're going to have, is our production environment. And I'm actually going to label prod, which is short for production, and you'll see me use that abbreviation, or not abbreviation, but shorthand quite frequently. I'm going to label prod as a group of entities, and that's because these entities may or may not live on the same computer. So for example, we're going to have our production database, we're going to have our production website, we're going to have our production Photon instance. Now, our database is self-explanatory. That's where all the data of the project will live. Our website is the place where users can go register accounts and download the launcher. And Photon is our server logic. So that's going to be our game servers, our master server, and our region server, or region servers. And the idea is that all of these can be on the same computer, or they can be separate. Now, in addition, the CI server in our particular instance is going to live on our, quote, production server, unquote. I'm going to be working with a VM that's going to act as the CI server, the production database, the production website, and production Photon. So I just wanted to point that out. For simplicity's sake, I didn't want to fire up multiple virtual machines. So,
alrighty.
Those are our computers. Development, Bitbucket, CI server, database, website, and Photon. Of course, if you wanted to have a more complicated deployment situation, for example, if you wanted to have a staging server where you could push changes to a staging server that's only accessible by your team and not your customers, you could very easily add that in using the exact same techniques that we are going to be outlining in the beginning of this project. Okay. So let's talk about projects.
All right, show me the magic.
So our Visual Studio solution is going to be comprised of a variety of class libraries and one ASP.NET web application. Now there's going to be a bunch of them, so I wanted to lay them out in a diagram just to be able to explain each one in isolation, so that when we go to create them, there won't be any confusion. At the base of our projects is going to be base. Now, base is going to be .NET 3.5 because the base project is going to be shared by both the client and the server, and the website, and the launcher, and everything. Now, the base project is going to contain everything that needs to be shared between all these other projects. And that includes things like RPC interfaces and different enumerations, and maybe like helper code that we'll write along the way. For example, an extension method to string that returns its MD5 hash or something fun like that. Next up, we're going to have data. Our data project is going to contain all of the code that's going to be required to interact with our database. The reason this is a separate project is because our servers and our website will have to use the information from data. So for example, data is going to contain things like our Entity Framework entities, entity classes, and as well as other helper classes that will be used with the micro-ORM that we're going to be using for the real-time data access. And we'll talk more about that later. Next up, we're going to have our base server. The base server project is going to contain all of the server code that is shared between the master server and the region servers, and potentially any other kind of server that we would want to add in the future. So the server base is going to contain that framework code, and we'll have a master server and a region server. Again, all of these are individual C# class library projects. Now, The base is going to be .NET 3.5. The data is going to be .NET 4.5.1, as well as the server base, the region server, and the master. Now again, the base is .NET 3.5 is because the client needs to be .NET 3.5. So the next thing that we'll need is our website. And our website is going to contain, well, the website that users use to register accounts with, as well as the APIs that will be used for logging in from within the launcher. We'll talk more about the logging in process later in this video. So this is basically our server-side stuff. So let's draw lines that indicate the relationships. Master is going to be using server base, region server is going to be using server base. Server base is going to need access to data as well as base. Data is going to depend on base, website is going to depend on data, and website's going to depend on base. So that's kind of our reference hierarchy of the server-side code. And these are, again, all of the projects in Visual Studio that we're going to be creating. But we still need a couple more projects. We need our launcher, which is going to be a WPF application written in .NET 4.5. We're going to need our client, and then we're going to need our Unity client. So launcher is going to depend on base. It's not going to depend on data or server or anything like that because it's a client-side component that the users of your application are going to use. Client is going to depend on base, and same with Unity client. Now, you might think, well, there has to be a lot of things shared between client and Unity client. Why do I make a differentiation between them? And why am I making Unity client depend on base but not client? And the reason is the relationship between client and Unity client is going to be kind of weird.
All right. Weird how?
So this stuff is going to be weird. It's going to be weird because they're going to share code, but they're not going to share projects or depend on each other. The reason for that is Photon supplies two client assemblies that you need to build against when working with either a Unity or a non-Unity client. They have the normal .NET SDK and they have the specific Unity SDK. That means the client code has to be built against either DLL, depending on if we're wanting to write a client that isn't in Unity or we're wanting to write a client that is against Unity. So our Unity client will contain links so it'll contain these soft links to client. And when we build our Unity client, it'll build using some of the same files as client and some additional files in order to work with Unity, and it'll link against the proper SDK. When we build client, it'll link against a different SDK, and it will, of course, not have anything Unity specific in it. In addition, obviously, the Unity client will be referencing the Unity engine DLL, which the normal client will not. So those are all of our Visual Studio projects, but we're also going to have two Unity projects. We're going to have our client, or I'll call this the game client just to avoid confusion. Our game client. And we're going to have our editor. Now, the game client and editor are both going to depend on Unity client. So why do we have two Unity projects? Well, the way that I'm designing this MMO is I want to leverage as much as I can from Unity. I want to extend the editor in such a way that'll allow us to use Entity in order... Use Entity? Really?
Or Unity, either one.
Unity, yeah. We'll go with Unity this time. We'll do Entity next time.
All right.
That uses Unity to make developing content for our MMO easier. So we'll be writing like custom windows that allow you to edit a quest, or we'll be building a system that allows us to modify grid cells, individual terrain cells for building our terrain in a way that'll allow us to create, well, basically terrains of unlimited size. So our editor project is going to contain a bunch of editor extensions and other fun stuff. It's also going to contain all of the code from our Unity client, and that is because I want the editor to have a very tight feedback loop. I want you to be able to work on a quest and then hit the play button directly within the Unity editor running the editor project and be able to test that quest instantly. I really want a tight feedback loop. So the editor is going to contain all the Unity client code. The game client, on the other hand, is going to contain all of the Unity client code, but it's not going to contain the editor extensions or other features that we're going to be decorating the editor with in order to make development easier. It's going to be basically a stripped down version of everything you see here, and is going to be what the customers of your product actually use to launch the game and interact with the world.
All right.
So we have base, data, website, server base, master server, region server, launcher, client, Unity client, and then we have two Unity projects, game client and editor. So again, the .NET 3.5 base will be .NET 3.5, launcher will be .NET 4.5.1, client and Unity client will both be .NET 3.5. Game client and editor are obviously going to be .NET 3.5 because that's what Unity supports as of now. So I hope that when we go ahead and launch Visual Studio and start creating the skeletons for our project, things will make a little bit more sense why we need so many projects. But as you should be able to see from this dependency graph, there's really no way to create fewer projects, or at least fewer projects that I can think of.
Well, in the end, an MMO is just an unbelievably massive project with every problem that you could ever think of. So, yeah, I mean, I just don't see how you could strip it down terribly far and still make it work.
Right. And I definitely want to avoid code duplication as much as possible, so that's why, for example, I have the data project, so I don't have to duplicate my Entity Framework entities between the website and the server base. Okay, so that's our overview of our project. So let's go ahead and talk about the process of updating the server, the launcher, the client, and the website. And again, this is incredibly important for what we're doing with the auto updater because we need to have the process of deploying new versions of the client down before we could even think about writing the logic of the launcher. So the actors that are involved with this sequence graph that I'm going to write, even though it's not really going to be a sequence graph in the UML sense, because frankly I can't remember half the things that UML specifies, so instead I'm going to be using my own version. That'll hopefully make sense. So what we're going to do is we're going to write down the actors involved. So the actors involved is going to be our development environment, so our development computer. Remember the one computer that has Visual Studio on it, as well as a duplication of the production environment. We're going to have Bitbucket. And Bitbucket, again, is the service that's going to be hosting our Git repository that's going to contain all of our code. Then we're going to have our database, production database. So I'll just write prod up here to specify that everything that follows is going to be considered our production environment and may or may not be on the same computer. We're going to have our website, and we're going to have our Photon. So what happens when we make a change and we want that change to be deployed to all of the customers using our application? Well, in development, we would make the change. So I'm just going to say make change, and we would push to Bitbucket. Those unfamiliar with Git terms, push means I take all of the changes that I made on my development computer, I wrap them up into a single entity, which contains multiple commits, and I send it off to another Git repository. In this case, it's going to be the Git repository stored on Bitbucket. Now, I did forget an actor here. So excuse me while I move these along and make full screen work again, because Photoshop sometimes doesn't want to work right. Oh, come on.
Oh, the list of things that I would pay $100 if somebody wrote a thing to change what Photoshop does.
So I forgot an actor, and that's our CI server. We need our... Oh, come on. This is just a cruel joke. CI server. Okay, so we push our changes to Bitbucket. Then we log into our CI server over the web interface, and we tell the CI server to request all of the changes from Bitbucket. So we'll do a pull. and that'll send all of the changes that I made to the repository to our CI server. Then the CI server builds things. What do I mean by building things? I mean, it compiles our projects. So for example, it will create a standalone. What I mean by standalone is a standalone player of the game client. It'll create a, it'll build a web package. A web package, we're going to be using MS Deploy for this, and a web package is a package of code that we're going to send off to our website to deploy the website, and it'll build our servers. Build servers. It'll also build our launcher. So the CI server is basically going to compile our entire repository into each individual package that we need to deploy somewhere. So after all 4 of these steps, we're going to have a bunch of build artifacts. Remember I said build artifact before is the result of compilation, or the result of a build process. So the first thing that we're going to do is we're going to publish our website. So the CI server is actually going to use web deploy to publish our website. Actually, we're going to be using MS Deploy, and web deploy is something that's built on MS Deploy. It's irrelevant in this case. Anyway, the fact is it's going to publish web package. So it's going to update the website. The website is now updated. When the website starts or restarts, it's going to migrate our database. What does that mean? Well, it means it's going to update all of our database entities, all of our database schema, so our tables and whatever stuff we put into the database. It might also add data or remove data or munge data in whatever way it sees fit. So the website, in this case, is going to be responsible for keeping our database up to date. And the reason I did it this way is because it's a lot easier to do with Entity Framework, because I can simply say on website start, migrate database. So it's very easy. So now the website is updated. The database is updated. Let's go ahead and update Photon. So we're going to copy our R is not spelled with an S. That still looks like an S. So copy our server build. So that'll copy our server build onto Photon, so that Photon can then run all of the updated code. The next thing that we need to do is we need to send our client and our launcher to something. So our CI server is going to go to the website and upload our launcher. And that'll tell the website that the next time a launcher requests the latest version of a launcher, that version will be out of date, and the launcher that's running will need to re-download itself. The final thing that the CI server will do is it'll upload client. So that means that the next time the launcher requests the latest version of a client, it'll receive that data from the website and it'll know how to download it. Remember, the launcher and the client itself will be stored on the website, which is one of the reasons why we're building the website first, so that it can host this data. Of course, the data itself will be on the database. So let's just run through this process one more time. And before I do that, I want to point out that these 4 steps don't need to be ran together. So for example, we're going to be building a variety of different build packages, or build configurations, on our CI server, one for each scenario that we want to target. For example, we're going to sometimes only make changes on the client, in which case we'll create the standalone project using Unity, and we'll publish we'll upload the client. Sometimes we'll only want to update the launcher, so we'll just build the launcher and we'll just update the launcher. Sometimes we just want to update the website. Again, we'll build the web package and publish it. And sometimes we just want to build the servers, so we'll build the servers and publish them to Photon. So again, you don't have to run all 4 of these steps on every build, and that's a good thing, because this right here, let me see if I can point to it enough so you guys know exactly what thing I'm pointing at. This thing right here, you see this? The create the standalone project? This is the bane of my existence. It takes it takes a very long time for Photon to actually build a standalone player, especially if you added a bunch of assets. You know, it can take up to 10 minutes if you add a bunch of assets. And we don't want our builds to take 10 minutes. In fact, in my experience, we can do all these 3 steps in under 20 seconds, including publishing them. And that's awesome, because then we have a tight feedback loop and we can push to production or staging or wherever very easily. But building a standalone player takes a long time, so that's definitely not something we're wanting to do if all the changes that we made were just on the servers or the website or the database.
Gotcha, makes sense. It's a real pain. We don't want to do it unless we have to.
Right. So I'm only including all 4 of these steps in this diagram for the sake of completeness, so I don't have to do 4 individual diagrams. So let's run through the process one more time. Our actors is the development machine, Bitbucket, which stores our repository, the CI server, which does our building and publishing, our production database, our production website, and our production Photon instance, which may or may not be on the same computer. The first thing that we do is we make a change. That's what started it all. This whole diagram happened just because we had the audacity to make a change to our project, to add a feature or fix a bug, or maybe to introduce a bug, because that's typically what happens instead. So we create a change, we push it to Bitbucket, which synchronizes the Bitbucket repository with our local repository. We then tell our CI server to do one of these 4 things, in which case it pulls the changes from Bitbucket onto our CI server, so our CI server has the latest version of all of our code. It then builds, so it creates a standalone, it builds a web package, it builds the servers, and it builds the launcher. Then it'll publish the web package by deploying the web package to our website. Our website will then migrate the database by updating the database schema and adding, removing, or munging data for whatever reason that we might have. Then the CI server will copy our server build to Photon, so that Photon has that latest version of all the code. Then it'll zip up and upload the launcher to the website, and then it'll zip up and upload the client to the website. There's one more thing that the CI server is going to do, but we're not going to see an example of it until later in the series, and that is it can actually do automated testing, meaning that our CI server can run our unit tests. Typically where that happens is it happens right here. We do unit tests. And again, unit tests are just automated bits of code that we write that exercises some of the other code that we wrote in some sort of way to make sure that we didn't accidentally introduce a bug. So we're going to have a lot of unit tests later on in the class, but building this particular system isn't going to necessitate we write any, so that's why I kind of left that step out until the end. But the cool thing about a CI server is that it can actually stop you from doing any of these things if any of the unit tests fail, which is really cool. It provides us a little sanity check to make sure that we didn't accidentally introduce a regression. In addition, there's one more thing that the CI server can do for us. Actually, there's a whole lot more, but that would be a video series in itself. The CI server can also run periodic integration testing, or integration tests. Now, integration tests and end-to-end tests are like unit tests, but they cover a larger scope. A unit test might be, I invoke this method on this class, and then this class invokes these methods on this other class. That's a unit test. An integration test might be, I instantiate object A, and I instantiate object B, and when object A does this, object B does that. The differentiation is that a unit test tests a unit, whereas an integration test tests a interaction between multiple units. Then we have end-to-end testing, which I really want to do some end-to-end testing. End-to-end testing is when you basically build everything like you would do in production, and you actually run a real client, and that real client then in an automated way performs some set of actions and expects some set of results. What I want to do is I want to schedule some of our integration tests and end-to-end tests to actually be ran on the CI server at a period of maybe every 6 hours if there was a change. So if we changed something the next 6-hour interval is going to run these tests. And the reason for that is that unit tests need to be fast and small and have no dependencies on external systems like file system or database, whereas integration and end-to-end testing may actually require access to a database or a file system, which makes them run considerably slower. We don't want to force the user to run all of the end-to-end and integration tests every time they build something. Okay, so that is our workflow for updating our logic in an automated way. It looks complex, but in reality, what we're going to do is we're going to have 4 buttons. And these are our 4 buttons. And we click one of these 4 buttons, and all this stuff happens. And it's all magical and happens really quickly, and it'll make your feedback loop very tight, and it'll save a lot of time.
I knew magic was involved.
Magic is always involved.
So it really seems like what we're doing is investing a lot of time in planning out how to do this so that we lessen our time down the road and lessen our time on the client end.
Well, yeah. We're making sure that we can put the stuff together. Well, another reason is to make sure that we can put the stuff together so that doing this in the future wouldn't be impossible. Now, this isn't going to be a lot of time. This isn't going to be a whole lot of code to write to make this work, which is why I wanted to put it in the front of this video series. But whether or not you do this at the beginning of your project, if you don't do this by the end of your project, you're going to have a miserable time maintaining your code base. If you want to make a small change to one of your components in production for whatever reason, because, well, once the code's in production, you still have bugs to fix, you still have features to add. If you don't automate the process, it is prone to error. And I've worked as a web developer for many years, and one of my first jobs, I worked in a place where we didn't have any sort of continuous integration environment, which required that every time we made a change to something in production, we had to manually build code, manually copy code, and it was very error-prone and slow. So either way, if you guys just want to ignore all these videos and not set this up in the beginning of your project, you can. But by the time you get to production and you're not doing something like this, you are going to have a miserable time maintaining your code base. Guaranteed. It might be that you are so used to that miserable time maintaining your code base that it might be like, why do I have to do all this stuff? But once you see this in action, you'll understand.
All I know is I saw the auto updater from the client side, and magic was the first word I used.
So let's go ahead and talk about the last thing. And the last thing is the process of logging in. So who are actors with logging in? Well, we have the client, or the launcher, sorry. We have the client. We have the website. We have the database. And we have the Photon servers, or I'm going to actually refer to this as the master server. Remember, we're going to have multiple Photon servers, but the master server is going to be responsible for authentication. So, launcher, client, website, database, master server. So, first thing you do is you launch the launcher. Now, after that, the launcher is going to go ahead and ask the website for the latest launcher version number. So, get latest v number for the launcher. The website is going to ask the database and return a result. Then it's going to, of course, return that result back to launcher, but I won't draw that line because I find that redundant. So then let's assume that the latest launcher version Let's assume worst case in this entire diagram, just so I don't have to write multiple diagrams. So the worst case is that the launcher is out of date and the client's out of date. So because the launcher is out of date, it now has to download the latest launcher. So DL launcher from the website. It then has to update itself, which I know there's a bit of graphical syntax I can use in UML to refer to an action that refers to itself in an actor. I'm not sure if that's the one, but the point of this line is to say that this action refers to itself, which is going to be replace self with the latest launcher. After that, it's going to ask the user for a username and password. So ask user for password. It's then going to validate with the website. So validate creds with the website. And the website's going to return true or false. It's going to return true if those are valid credentials, a valid username and password, and that particular user can or does have the permissions to download the latest client. Let's assume that this is valid, because if it's invalid, the process stops here. So let's assume that these are valid credentials and the website returns true. The next thing that the launcher will do is it'll query the website. Wow, these lines are getting worse and worse.
Shift, man, use shift.
So get latest client v number. So it's going to ask the website for the latest client version number. The website's going to ask the database for the latest client version number, blah, blah, blah. Let's assume that the latest client version number is greater than the client that's currently downloaded with this launcher. So then what it's going to do is it's going to download the launcher. Or, sorry, download the client. So DL client. It's then going to replace the client with what was downloaded. Now, this is where things get a little tricky. So far this is pretty straightforward, I suppose. It asks the website for the latest launcher version. It downloads the launcher. If there's a difference, it replaces itself. It asks it user for username and password. It validates credentials. It gets the latest client version number. It downloads the client, replaces the client. Pretty straightforward as far as the launcher goes. This is where things get a little crazy. The goal of what I'm about to write here, the sequence diagram that I'm about to write, is to not have the username or password asked of the user 2 times, but to require that the launcher is able to validate the credentials. So what does that mean for me? Well, it means that the actual game client itself, I don't want it to ask for the username and password again, because the launcher already asked for the username and password of the user, well, before it downloaded the client. So the way that I'm going to handle this is the launcher is going to then send the credentials again to the website, and it's going to ask for auth token. Now, what's an auth token? In this context, I mean an auth token to be a randomly generated string of numbers. That line was a little bit too far. All these lines are a little bit too far over, actually. So what happens here is the website gets the credentials again and gets asked to create an auth token, in which case it stores the auth token in the database. So it generates, I'll just say gen/store token. So the website will then generate a token, a random sequence of characters, and save it in the database. And then it'll return token. Let's see if I can get some more space out of this. I might have to increase my canvas size. That's okay. And that line, oh man. I don't like using shift line because then it doesn't look like I wrote it, you know? And the lines start to like one-up my handwriting, and then I get jealous.
All right, fair enough.
Okay, so now the website has generated a token and it's returned it to the launcher. The launcher will now, let's zoom out. I have to increase my canvas size. Give me a second. Image, canvas size, grow from here. No, grow from there. Let's do 2000. And then let's come in my background. I can't find my B key, guys. Where's my B key? There we go. Alright, sorry about that. So, we now return the token to the launcher, and then the launcher will finally do what its name says and launch the client with the token. Okay, so now the launcher is out of the picture. The launcher's process is exited, and the client has been launched. And the client is launched with the token that was returned by the website that was generated by requesting the user credentials. So now what happens is the client will then log in to the master server with the token. So log in with token. So this way, the master server will be able to query the database for the token and retrieve information, such as what user generated that token. Is that token valid? Was the IP address of the person who generated the token the same as the IP address as the client that launched? And so on and so on. So the master server will validate the token. So we'll say validate. Validate has a T in it, doesn't it?
It does.
Validate token. And then it'll finally come back to the client and tell the client who he is. So send client info. At which point the client can connect to the appropriate region server, launch the game, and start the whole process. So this looks really complicated, but really the goal is, there's a couple goals, a couple things that I accomplish with this sequence diagram. First of all, the launcher and the client are two separate entities and can be updated individually. I really wanted that because, well, I mean, you guys have seen MMO launchers before. There are features that are added to MMO launchers. I didn't want to force the user to have to re-download a launcher every time it changed, but I also wanted the launcher to be able to change and be updated automatically. So that's why we have two kind of very similar steps. We get the latest version number of the launcher, we download it, we replace it. We get the latest version number of the client, we download it, we replace it. Because there's two different things that we're updating, depending on what changed. The next thing is the username and password is asked for in the launcher, but I don't send it twice, or I do send it twice, but then I receive a token that I'm able to log in with. The reason I wanted to launch with a token instead of just sending the username and password with the launcher to the client is because the only way to send data to Unity without resorting to writing to the file system is to send it with a as a command line parameter, and I didn't want that command line parameter of your password in plain text being visible in your task manager, for example, if you were to launch your task manager and view the parameters of the process used to start up. If I had passed the username and password into the client itself instead of the token, then your password could show up in the task manager in plain text, and that's just kind of embarrassing, and I don't want that to ever happen. So,
Alrighty.
Yeah, let's just run through this process one more time, and that'll be it for the overview. So, launcher gets latest version number of the launcher from the website. Remember, the website is what the CI server is going to deploy to when it updates the launcher. That'll then check the database. It'll download the launcher, it'll replace itself. It'll get the user credentials, it'll validate them again with the website. We haven't talked to Photon just yet. We then get the latest client version number, assuming that the username and password was valid, and the website retrieves that information from the database. Again, the client is uploaded to the website. We download the client, we replace the client, Then we generate an auth token for the website, which then generates and stores the token in the database. It then returns the token back to the launcher. The launcher launches the client, passing in the token as a command line parameter. The client then logs in with the token to Photon. Photon checks the database for the token, validates it, and then sends the user back the information, like what character they are. And that's really all there is to it. So, between our computers, our projects, our updating process, and our launching process, we've pretty much covered the high-level overview of everything that we're going to be doing in the first section of this series. So let's go ahead and get started.
All right, great.